So the question we are studying is homework 4, question 6. We have two systems. The question is whether they are invertible or not. Let's look at the first system first. Every time I look at these piecewise systems, the first thing I do is to try to really understand what does this system do. Okay, so let's give it a try. So therefore, if my x of n is this signal, again I'm giving an arbitrary signal. This is x of n. Now the first goal of mine is to understand what the yn is going to look like. Okay? How do I do that? When n equals to 0, what is yn?
0.
Very good. When n equals to 1, what is yn?
X at 0.
x0. So I'm copying this one and replacing it here. When n equals 2, what is my yn?
X at 1.
X of 1. So I'm copying this and replacing it here. N equals to 3, what is my yn?
X at 2.
X of 2. I'm copying this and replacing here. Is this part clear so far? How about y negative 1?
X at negative 1.
X of negative 1, so therefore I'm copying this one and replacing it here. How about y negative 2?
X at negative 2.
X of negative 2, so it's going to be this. Okay. So now can you tell me in words, in English, what does this system do?
Well, if n is negative, it's just whatever x of n is, but if it's greater than 1, you just shift x.
Shift everything from 0 onward and insert a 0, right? So this one is going to be sent to here, and this one is kept in the same position. Now go back to our original question. Is this one invertible or not?
Yes.
It is invertible. How do you invert it?
Well, I guess you can get rid of the 0 and put it in like n is greater than 0, and then make it y of n, and then
So the idea is, every time I look at the output signal, I'm going to get rid of this 0, move everything back. That will give me the original signal, right? Whatever signal I have, I'm going to get rid of the 0, move it back, and then I get the signal here.
so then you just get y of n is equal to x of n.
Say again?
You get you get like x of n is equal to y of n.
After this operation, the new signal will be back to the original input, right? I receive the output, they are not the same. But after this operation, I remove the one in the center, move this part back, I'm going to get my original signal. That is the inverting the signal, right? I start from any output, I do additional operations, finally I'm going to get my original output, original input.
Okay. So then you get y of n plus 1 for n is greater
Your
than
question is, how do you write it down mathematically? Okay. If you notice that we didn't require you to know how to write it down, because writing it down usually is harder, it takes more experiences. But intuitively it's straightforward, right? Look at the figures, you know how it looks. Right? So if you really want to write it down, what you can do is you write xn is yn if n less than negative 1 is yn plus 1 if n modulo. So basically, again, it's just formalize the operation that you keep everything on the left, everything on the right, you shift it back to the center. Have I answered your question? Let's now try to solve a different question. So yn is, let's say, is this. So if x N is delta N. What is Yn? What is Yn? So now, out of all this, everything, only one of them is non-zero. Only when k is what is non-zero?
N?
K is 0,
Oh.
right? Xn is delta n, so
Right,
xk
right.
is
Okay.
only non-zero when k equals to 0. So even though it looks like I have infinitely many terms, how many terms I actually have? I only have one term, and that term is
1/2 to the
Half.
power of negative k. Or k is, oh sorry, k is 0, so 1/2 to the n.
yes, very good. So it's going to be 1/2 to the negative, to the positive n. That is the signal. Here is one here, one in the center. So far so good. Now your goal is to do what? To create another signal that gives you the same output. If I can do that, it is
Invertible?
it's not invertible.
Oh, right, okay.
Right? If I can do that, it's not invertible. Right? Is the goal clear to everybody? Right? We try to find another signal such that it gives me the same output. But it doesn't, I don't know how to do that, but let's just try one thing. If it's 1 here, it's a shifted version. So this is 1. If my input is this, what will be the output? So this is my input is this one. Out of infinitely many terms, how many are non-zero?
Just 1.
Which is when k equals to
1?
1, very good. Therefore, the term out of infinitely many terms, what is the remaining is
1/2
half.
n -1.
n minus 1. Very good. Therefore, if you plot it, 1/2 n minus 1, if you plug it in, you get another decay signal. But the height is 2 here, so it's decay, but the height is 2. And they are not the same. So therefore, I'm not there yet. But it turns out I can manipulate this a little bit to make this one the same as that one.
If you shift it to the,
Shift it to where?
to the left?
To left, but then this go back to here, right? Obviously you are right, go back, you get the same thing. But I want to do something other than shifting to make these two identical.
You change the height of
Very good. What is the new height?
1/2?
Very good. So if I change this to half,
Oh, then everything else is half.
everything else is half, so therefore the height becomes 1. These two signals are identical.
Okay.
Now we created what? Two signals,
That were different that produce the same.
same input, so same output, therefore it is
Not
not invertible. So the answer is it's not invertible.